So in problem number 1 from homework number 2, we are given a graph of two waves at t equals 0 seconds, which is shown at the top. And we are asked to draw 6 snapshot graphs stacked vertically showing the strings at 1 second intervals. So I went ahead and everything in red is going to be a redrawn graph or me explaining how I achieved these graphs, why some graphs didn't change, or why some look the same as they do in T1 and T5. So at T1, when we move to the right 1 second and to the left 1, the only place that the graph overlaps or where they run into each other would be at 5. So when this wave and this wave run into each other, they meet at 5. There's no overlapping elsewhere. Because of this, the graph isn't going to change, and I redrew the graph in red, and as you can see, it is the same as it was in blue. As for t equals 2, you see there is some overlap, and in these areas where I drew this little line, there's no overlap. And because there's no overlap, we kept that area the same. So as you can see, from 2 to almost 4 and from 8 to this area, it's going to be the same. But once we reach that 4 second mark, I am going to draw a bigger dot in red. So at 4, we see that the displacement of the bottom graph is 0 and the top graph is 1, which is where we get this 1 height from. And same goes from 6. The displacement of the bottom graph is 1, top graph is there. So because it's 1 up here and 1 down here, we know that our graph is going to have to look like this. But between this area, this is all the same. This is the positive value, this is just the negative value. So when you take the difference, it's going to equal 0, which is shown when that area touches 0. So it's just like connecting the dots. So this is the same, this dot, that dot, back to the same. And once we reach t equals 3, so the new graph at 3 seconds, you can see the waves are fully overlapping and they meet each other. So you have the displacement at 5, let's say, is 1. But at here, for the bottom graph, it's -1. So when you take this difference, it's going to equal 0. But since both waves overlap at every point, every area is going to equal 0. Therefore, we get just a flat line at t equals 3. And at t equals 4, it's going to be very similar to t equals 2 seconds, which is seen right here. Essentially, it's just flipped because now the graphs are moving away from each other rather than going towards each other. So at these 2 points, the graphs do not overlap, which is why they are the same. And then once we get to t equals 4 and t equals 6 again, the displacement of the top graph is going to be 0. The displacement of the bottom graph is going to be 1. So we go from the same all the way down to 1, and then that area near 5 that is the same at the top, the same at the bottom, when you take that difference, it's going to have to be 0. So then you have 0, and then right here the displacement of the bottom one is 0, displacement of the top is 1. So we go from where it's the same, to that bottom displacement to where it's 0 because both the top and the bottom are the same, to the top displacement to where they don't overlap. And then this graph is going to be the same as this graph because they only meet at this point, but the rest of the waves do not overlap. And because of this, the graphs are going to be the same, which I redrew in red once again. And lastly, for the t equals 6 graph, it's going to look very similar to the t equals 0 graph, just in the opposite direction. The two waves do not overlap at all, therefore there is no need to redraw a new graph. And I hope this makes sense. Once again, the red is just what I did, the new graph. It's basically just connecting the dots wherever you're finding the difference, drawing that dot and connecting it. And that is how you would draw graphs from two waves that you are given.